This episode is sponsored by Optify. Optify is a taskbar applet for Windows and Mac OS that helps you keep track of your device's Wi Fi and network connection information. With Optify, you can easily monitor crucial details like channel widths, signal strength, access point manufacturers, and more, all from a small window that sits conveniently in your taskbar. Plus, with live remote monitoring, you can even share data with remote users and get real time analysis. Just create an account at app.optify.com to access customized presets and take your network monitoring to the next level. Download a free trial at optify.com. Hey, everybody, welcome to a brand new episode of the Clear to Send podcast. My name is Roel, and I'm here with Francois. How are you doing, Francois?
Very good. Happy to be recording with you, Roel, today. And we have actually, technical subject. It's
Yeah.
been a while for us, so it's exciting to actually get back into the technical aspect of the Wi-Fi protocol. So I'm excited about this one.
Yeah, it's like a lot going through a lot of learning that we've been going through. Uh, I've been in the middle of testing OWE. That's our subject today, Opportunistic Wireless Encryption, and I've been testing it here in my lab and then pushing it out into one specific building on our campus to see how these devices connect. I'm happy because I have 50% of devices actually connecting with OWE. So I'm doing it in the transition mode, and we'll get into that. But we're going to talk about OWE, what we think about it, what are some of the things to look out for with OWE and the OWE transition mode. And then we'll kind of dive into some of the wireless packet captures that we have because it's going to be interesting to see what you need to look out for in terms of the configuration. Like, are you really looking at OWE or is it OWE transition mode? So, what do you think,
Mhm.
Francois?
Yeah, I think OWE. So we'll get into what it is, but it's very interesting right now because the device support for OWE is not there yet. It's kind of slowly getting there. So we have some interesting findings and looking at the frames, looking at the Wi-Fi scanners. It's always interesting to see. When we start using new technologies. So hopefully we can kind of showcase all of this to you guys today. If you're listening to this audio only, we'll be showing some pcaps, some Wi-Fi scanners, some images. So if when you get a chance, we'll try to be as descriptive as possible as often. But if you get a chance, definitely check out the YouTube video or the show notes, and you'll get the visual on top of the audio.
Yeah. So, why don't we first describe what OWE is, right? So earlier I called it opportunistic wireless encryption. Uh, that's what it is. And what OWE does is secures open SSIDs. So with open SSIDs, we're used to just creating an SSID without a pre-shared key, without 802.1x. It's just an open SSID, right? It's generally an SSID that people and even operating systems declare as unsecure, right? It's
Mhm.
going to be your wireless transmissions are transmitted in the clear, and you hope that your applications are actually encrypting all of that traffic for you. Is there anything else you want to add to that, Francois?
Yeah, that's typically the way we do open Wi-Fi today or guest Wi-Fi. It's just an open SSID, no authentication, no encryption at the layer 2 level. And like you said, we're relying on the applications. Usually it's, SSL layer 7 to kind of do the encryption for us. With OWE, what we're trying to do is we're adding encryption at the layer 2. So we are when where the for the I mean, from the standpoint of the user, it would be the exact same user experience. He clicks on the SSID to connect to the guest Wi-Fi, but in the back end, with OWE, we're going to do some exchanges to actually create some encryption, generate some keys, so we can actually encrypt the data layer 2. And so even if someone is trying to listen to the frames, they won't be able to see the information being encrypted. So there's no authentication, but there is encryption with OWE on public networks.
Yeah, and I think that's what really the cool part is about OWE is how it encrypts the at least initially the traffic between the device and the AP in order to kind of create that privacy there. And the way they do
Mhm.
that in the frames, we'll go into that. It's really neat. So I personally like OWE because we use open SSIDs, and I do see a lot of other open SSIDs out there, right? Just makes it easier for devices to want to connect to the Wi-Fi network without having to search or ask for a password. And
Mhm.
we're just adding encryption there, and I think that's good for our industry. I think the one thing to look out for with OWE is that in comparison to something like 802.1x, with OWE, there's no mutual authentication, right? You're just trusting that the AP that you're connecting to is indeed
Mhm.
the real AP broadcasting that SSID and not some um, imposter
Mhm.
malicious actor.
Hmm. Yes. Yeah, like you said, there's no authentication, there's just encryption. So, I mean, like you said, you could be connecting to a hacker and sending him encrypted data, and he'll be like, "Okay, I'll take it. I'll decrypt it since I'm just negotiated the keys with you,"
Yeah,
and he'll be happy to do a man in the middle. So we'll still have to be careful about the authentication piece. I mean, if I think if we want to in the future get like a full on secure guest network, we'll have to go with something like open roaming, where they're using .1x to do the authentication on top of doing
yeah.
the encryption. But OWE, I mean, it's the reason why we talk about it so much right now. It's because it's mandatory for open and guest networks on 6 gigahertz, and we slowly, starting to deploy 6 gigahertz. So if we want like a public network on 6 gigahertz, we have no other choice but to use OWE.
Yeah, I think it's important to mention the configuration portion, right? Because you may
Mhm.
have a single SSID, you have it as a dual band SSID currently 2.4 and 5 gigahertz. It's configured as open, but then now you're enabling the 6 gigahertz portion. But when you enable 6 gigahertz, you do have to configure that SSID being broadcast on that frequency as OWE. It cannot be open. It is not an option for 6 gigahertz. And so
Mhm.
when we talk about configuration, there are different methods in which you move over to OWE. There's different ways to do it. There's good discussions from WLPC about transitioning to new security methods and over to, with 6 gigahertz. So there's a lot of those, and I think maybe we'll talk about transition
Mhm.
methods also in more in depth in a different episode as we do more of these rollouts. But for now, we're gonna dive into the technical aspects of OWE.
Yeah, so maybe what we can do, Roal, is talk about OWE, show like the frame exchanges, and see what's different from our typical open Wi-Fi networks, and then maybe at the end we can talk about the transition mode and see what's different with the transition mode for
Yep.
OWE, and we can take it from there.
Okay.
So yeah, I guess I can share my screen. You tell me if it works, but on your website you actually came up with a really nice infographic of what the frame exchanges will look like if you're using OWE. Can you see my screen?
Yes, I can see it.
Yeah, awesome. So what will happen, we'll have the typical probing process where the clients will send a probe request to the AP for a specific SSID. The AP will respond with a probe response. And then after that, we'll start with the authentication. And the authentication, it's the same. It doesn't really changes from what we're used to today with open network. So we are using what we're calling the 802.11 open system authentication, and it's just like a two-way frame exchange between the client and the access point. The client will send an authentication request, and then the AP will answer with an authentication response. So far, nothing different from what we've used to. The real difference happens in the association, right? So in the association process, the client will send an association request to the AP, and in this association request, the client will notify the AP that it wants to use the OWE AKM, and And then the AP will respond in the association response saying that it agrees to use OWE. And what the AP and the clients do in that process is that they do like a Diffie-Hellman exchange to generate the PMKs. So to generate the pairwise master key that will be then used in the four-way handshake that will follow, right? So instead of deriving the PMK from the authentication methods, and that's typically what we do with WPA2 or WPA3. Here we don't really have any authentication, so we're using a Diffie-Hellman exchange to generate those PMKs, and we use the association request and association response frames to do that Diffie-Hellman exchange, and we'll show you what it looks like in the frame in Wireshark, but it's just another information element that's added on top of the association request and response frames to make this happen. And at the end of the association process, the client is associated, and then we have the PMK that's created on both ends, so on the AP and on the client's side of the communication. And then we can just do a typical four-way handshake to generate the PTK that will be generated, that will be used to encrypt the data traffic. So what you'll see in the frame exchange is authentication, 2 frames, association process, 2 frames, the four-way handshake, and then you'll start to see encrypted data frames.
Yep. Awesome.
Hopefully that was clear enough for the audio. Yeah, I know it's not super easy to do all of these frame exchange stuff over the audio, but hopefully it was clear enough. What we can do here is we can go straight in Wireshark. So I'm going to navigate in Wireshark, and in the Wireshark I've kind of filtered, with the authentication frame and the association frames, as well as the EPOL frame, so we can actually see the four-way handshake. And here, what you can see in the Wireshark is we have the 2 first frames, which are the authentication. So if I click on the first authentication, you can see that under the 802.11 wireless management section in Wireshark, it will tell me that we're using the open system authentication here. It's written open system, so it's the same as what we're used to with the I guess the old school open network. And then I can see that the AP is sending me another authentication frame and telling me that, the open system is successful. So then we can move to the association request. And this is really where, we have the interesting new stuff. It's in the association request frame. Um, and and here, if I dive inside the packet details of the association request frame, under the tagged parameters, so where I usually have all of these information elements about the SSIDs, the superiority rate, and so on, when we use OWE, we'll look at 2 specific information elements. The first one will be the RSN, the Robust Secure Network information element. This is usually where we have information about which security is used for that connection. And here, if I open up the RSN information element, you will see that the authentication key management suite, what we call the AKM, is specified to Opportunistic Wireless Encryption, OWE, right? So here, the client is telling the AP, I want to associate using the OWE AKM. And alongside this RSN information element, if I keep on scrolling down in the list of information element, you should see something called OWE Diffie-Hellman parameters. And this is a new information element that we'll use to actually do the Diffie-Hellman exchange. And inside that information element, you will see that the client will specify which type of, I guess, a little bit more encryption details, cryptographic details about how they want to do the Diffie-Hellman. So for what I have in my example here, it's specifying the 256 bits random ECP group, and then it specifies its public key, right? And I believe they use, in this case, they use the elliptic curve, way of generating the keys. In the maybe we can take a look at the RFC later, but in the RFCs, they define 2 ways of actually creating the keys using Diffie-Hellman. There's the elliptic curve, and there's another way. I forgot the name, but but this is here. Looks like they're using the elliptic curve to do it. And then the AP. Now, if I look at the association response, so what the AP is sending back to the client, same thing. If I look at the packet details and the information elements, you will see that we have something called OWE Diffie-Hellman, and we'll have the same information here. So the AP has agreed to use the same method to create the PMK, to generate the PMK using Diffie-Hellman, and it's sending the public key as well. It's public key,
Mhm.
right? And at the end here, at the end of that process, both the client and the AP should have the PMK. And then you can see in the frame exchange that the association is followed by the four-way handshake, and this is a typical four-way, four-way handshake with the four different messages: message 1, 2, 3, 4. And if we look at the four-way handshake messages, they are the exact same one as the one you would see if you're using, a WPA2 personal, for instance, or a WPA2 enterprise, WPA3 enterprise, WP3, SAE as well. So it's just a typical 4-1 handshake that allows the creation of the PTKs. And if I add, I guess if I remove some of the filters here, or if I filter on the actual client in Wireshark, then we should start seeing some encrypted data. So I'll have to, let me just think for a bit here. I'm just going to prepare a new filter. I'm going to filter on the address of the client I was using. And in this case, I didn't mention this, but uh, I was actually testing OWE on 6 gigahertz using a Pixel 7. And then you can see that right after that, you'll get some traffic, some data traffic. And if I look at the data traffic, you'll see that the data is encrypted, right? So this is connecting to OWE network on 6 gigahertz, and starting to send some encrypted data. And one thing I guess that could be interesting as well to mention is PMF is mandatory for OWE, right? So protected management frames is mandatory for OWE. So if I scroll down in my capture, you'll see that I have some action frames as well. And an action frame is a management frame. And if I look at the action frame, you will also notice that the action
It's
frame payload is
encrypted.
encrypted. Yeah. So here I can see that there's some action frames. I don't really know what type of action frames they are, but I can see that PMF is working because the data is encrypted. So, we could guess maybe it's a neighbor report request or something like
Yeah,
this, but we're not sure
yeah.
since they are encrypted.
You're gonna see a lot more action frames with OWE and WPA3 because PMF is required. That's great.
Yes. Yeah.
That's a good
So,
overview of OWE, how it works.
yeah. And I guess what I can show as well is, um, should we get look at the RFC? I know we usually don't look at RFCs. Because as you can see, they're pretty dry. But this one is actually not super long. It's RFC 8110 or 8110, or 8110. I don't know how you you would say that in English, but and it's called Opportunistic Wireless Encryption. And it's they actually they detail the cryptography and the different information elements. So you can see they have a cryptographic section and then the OWE discovery association. So if I scroll down to the sections, you'll see that they give us a little bit more information. They're telling us that a Diffie-Hellman exchange is required. They're telling us they can do it either by using elliptic curve cryptography, or the other ones were the finite field cryptography. And they have nice acronyms for that: ECC and FFC. And they tell us that if it is ECC, so if it is elliptic curve cryptography, then depending on the key, um, depending on the size, they have the hash algorithm will depend on the size of the prime defined in the curve. and that they have SHA-256, and I believe that's what we're using. If I go back in my Wireshark and look at the association request, and I look at the OWE information element, let me just collapse everything so it's easier for me to show you guys. So if I go back to the OWE information element, you'll see that it's specifying 256 bits ECP. So it's a ECP and ECC. So I'm guessing it's similar. I'm not too sure about the P in the ECP,
Yeah,
but
me either.
yeah. So
I'm not
so
quite
they
there
give,
yet with cryptography.
yeah. I'm guessing the EC means electric curve. Uh, so it's giving us that information. Then it's telling us, how the OWE discovery is working. So here they're telling us that the AP can, when it sends its beacon out, it can specify under the RSAN information element the AKM suite for opportunistic wireless encryption, and the number is 18. So they detail that here, and this is what you'll see in the frames. And then they detail the OWE information element for the association. So they tell us the different field, the length, the extension ID, which will be 32. And then we have to specify the group and the public key. And this, matches exactly what we have in Wireshark. You can see the
Yeah.
length, you can see the Diffie-Hellman parameter number, and then you can see the group and the key. Um, so it's nice when we can actually read these type of standard documents, and then take a look at the frame and actually see the
Yeah.
exact same thing.
It makes
And
sense to us.
it definitely makes sense here. It's not that hard to read in this instance.
Yeah, the RFC was great to read. It wasn't super long. It wasn't overly complex. It was, and it made sense when you mapped certain things to the Wireshark capture. So they did a great job there, and hopefully, you guys can do the same thing in identifying that as well. But when we talk about OWE, right, that is a set parameter in your WLAN configuration. But what is the problem with enabling OWE right off the bat? We'll be right back to the show. This episode is sponsored by Optify. Optify is a taskbar applet for Windows and Mac OS that tracks and displays all of your devices' Wi-Fi and network connection information. The applet consists of a small window that appears in the bottom right corner of the screen. The Home tab will show you the name of your current Wi-Fi network, what channel widths it's operating on, and the access point's manufacturer. To the right of this is your current signal strength, followed by a copy button, which will copy all of that information in the top bar. And now the latest version of Optify Agent supports live remote monitoring. Click on the share icon in the bottom right. From there, you can choose between sharing via a share ID or a randomly generated URL. Then press the play button to start sharing data. Send the URL to a remote user and have them open it in a browser of their choice. Now, the remote technician can view all of this network data in real time. By creating an account and signing in online at app.optify.com, you can create customized preset tabs to display different sets of information for analysis. Right. Francois, you
Yeah.
mentioned earlier that some devices don't support OWE.
Yeah, the problem with OWE is because it changes the way the association work. You need to make sure that the client device actually understands these new AKM, can actually use these new AKMs can actually do the Diffie-Hellman exchange, and that requires the Wi-Fi driver to be updated to actually support OWE and do all of this work behind the scene. And what we've seen is not all devices or not all OS actually do support OWE today. It's we're actually making progress, and we're seeing updates very often right now. But you may find yourself into a situation where some devices are just not able to connect to OWE network, which is not ideal for a guest public
Yeah,
network, right? Ideally, you would want anyone to connect to a public
correct.
network. So
Yeah,
that's
so
kind of like puts up in a challenging place.
yeah, because you don't want to create two guest networks or two different SSIDs, one called secure, one less secure, right? You don't want to do that. So the way that OWE is being implemented is you have this thing called OWE transition mode. And the transition mode allows you to connect devices that are OWE supported and have them use OWE. But if you have a device that does not support OWE, it steps back and uses just the open framework, right? So it's just going to be your regular open network. But how does that happen over a WLAN, right? So Francois showed us the frame exchanges for OWE, and that in your WLAN configuration, you are specifying OWE. With
Mhm.
your wireless system, you will have another option called OWE transition mode. Now, the naming of that may not be the same across all vendors, but from what I've seen, it is just called OWE transition, and it
Mhm.
changes the way your SSID will be displayed to a device. So, what I'm going to show is what the frame exchanges look like for an OWE transition SSID. And so, Francois, do you see my screen?
Yes.
Okay. So I have the same kind of frame capture, and really the difference is going to be in the first few frames. So I have my device here. For one, I have an SSID called Open SSID, and this is in the 5 gigahertz. So it's on channel 36. You see the SSID for a probe request, Open SSID. Now my access point responds back saying, "Hey, yep, we've got Open SSID, right?" So if I go down to the bottom now and look at those frame details, you can see down below, right here, there is a uh, Wi-Fi Alliance OWE transition mode right there. Right. So if we expand that, now what this is saying is, hey, this SSID is OWE transition mode. It has an option to use OWE. So if a device supports it, it will see this information element here, and that device will see the details here saying, hey, access point is saying if you support OWE, you should actually associate join to this SSID right here where it has OWE in the front. So instead of just open SSID, it's OWE dash open SSID. Now, the
Mhm.
interesting thing about this transition mode is the actual OWE SSID is a hidden SSID. So if you're doing a scan, you won't initially see it, right? You'll need devices
Mhm.
to connect to that SSID in order to then see that hidden SSID. So this really means now, instead of configuring one SSID, you really are configuring two. The second one is configured for you in the backend. And when a device does support OWE in this transition mode, it will then make a second request. So my device is supporting OWE, sees that open OWE SSID in this Wi-Fi Alliance OWE transition mode element, and then it does a second request saying, "Hey, I want to probe for," and I'm gonna collapse all these as well, like Francois did, but I want to connect to the OWE dash Open SSID, right? And this is where it looks a lot more similar to what Francois was showing us in his frame exchanges, because now we are talking about OWE here in this case. AP responds to that OWE dash open SSID, goes through authentication. It's the same uh, open system authentication. Then we go through the association request. You can see it's still open OWE dash open SSID. We have an RSN information element. You can see it is using the AKM of OWE, and then we have the OWE Diffie-Hellman parameter, same thing, right? And
Mhm.
then the four-way handshake, see action frame, everything's now encrypted. So really with OWE, again, with OWE transition mode, your difference is that you will initially do a probe request for that SSID, the open SSID that I have configured. It's actually open, but then anything supporting OWE will join or probe for the OWE dash whatever your SSID is. And so far, that's how I've seen the open or the OWE transition SSID configured. Is that the same from what you're saying, Francois?
Yeah, and what I find interesting as well is, in the probe response and the information element you showed, where it tells you the SSID of that OWE. Yeah, this one OWE SSID. It also gives you the BSSID, right? So the
Hmm.
client will know which AP to directly talk
Yeah.
to, or which BSSID to talk to, in order to actually connect to uh, the right BSS. Yeah, this one too. That's quite interesting, and it only adds like a couple of frame exchange with transition mode, and you allow people to connect even if they don't support it. And I'm guessing that will help us also to be able to deploy the same SSID on both, 5 gigahertz and 6 gigahertz.
Yeah.
If you start to deploy 6 gigahertz.
Yeah, exactly. So this kind of simplifies that setup rather than creating separate SSIDs or even a separate one just for 6 gigahertz. So there's a different ways to do this, right? And I do have the AP name here. You can tell I'm using Mist AP here in this case. What I want to do is actually test it with a couple different vendors to see how different they implement it, because I don't think this is specifically defined where there is room for basically a difference in how the vendors can do it. But so far, this is what I've seen. And of
Hmm.
course, if you've got a device that doesn't support OWE, it just won't see the that information element from the probe response, and so it'll just join to the open SSID with the open system. And that's really the difference between OWE and OWE transition. And from there, it just becomes more of a deployment, right? Deployment
Hmm.
method. Which one should you use? Which one do you prefer? And I think for higher education, I believe we're gonna have to use transition mode, because we just don't know what kind of devices are out there. A lot of times we're dealing with devices with old operating systems, old drivers, so they don't even support OWE. But
Hmm.
even yesterday, when I was looking at connected devices, I saw an Apple Watch connect with OWE. But uh,
Wow,
yeah,
interesting.
that was interesting. So I'll have to get that capture and see what that looks like. Because the
Okay.
Apple Watch connects to whatever SSID the phone or yeah, your phone is connected to. And so I don't know if it's just directly connecting to the SSID using OWE.
Yeah, I think just like you, I think that the nature of a public network is it's just available for everyone. So if we configure it as OWE only, we may have problems with people not connecting. So I think most organization will use transition mode for now, just to make sure that people can still connect without
Yeah,
having
without
issues.
issue.
And then you just have, like, from the implementation standpoint, you just have to be aware that you're actually generating two SSIDs instead of one.
Yes.
So you have to think about your SSID overhead and all of this.
Yeah.
You just have to be aware of this. But I mean, if you that, and that's another problem we have nowadays, like you said, with transition methods and moving to WPA3 also on the other side of things. I think we're going to have maybe a little bit more SSIDs for the time being. um, Maybe we can help us by maybe increasing the minimum data rates a little bit to kind of send all of that management traffic a little faster over the air. Um, but well, I guess we'll have to do it if we want people to connect. I guess we'll have no other
Yeah.
choice in the meantime. Yeah.
Yeah, I think right now it's a learning process for all of us in terms of how we implement this, because
So should we look at what it looks like in a Wi-Fi scanner?
yeah, let's do that.
You let me know
So
when you
let's
see my
see.
screen.
Yep, I can see it.
So here I have I broadcasted the OWE network SSID, I guess, on my APs, and I've enabled transition mode. So you can see that in a Wi-Fi scanner, I can see, 4 BSS IDs here, and that's because this AP is dual band, 2.4 and 5 gigahertz. And you can see that one is called OWE. There's no lock on it, which means it's an open network. But if I look at the security columns here, it's interesting because it's telling me that it's enhanced open. So it detected that it had the Wi-Fi Alliance OWE transition mode information element, and it adds this information in the security column, right? So I can see it's an open network, but I can see that it is enhanced open,
Yeah.
meaning that there's a OWE available somewhere, and then I can see my OWE BSS ID here. So the network name is hidden. I have a little lock which tells me that it's going to be encrypted, and then I can see that under the security columns it's telling me OWE, and I can see, if I look at the detail about the information elements, I can see my OWE um, information element, and under the RSN, just like earlier, we can see the AKM for OWE.
Yeah.
Exactly how we saw it for in Wireshark OWE here.
Yeah.
So this is what
This
you'll
is
see.
excellent. Yeah.
Yeah.
Especially if you don't want to do the whole process of capturing wireless frames and you just want to see it, using Wi-Fi Explorer is a great way to do that with a Mac. Uh, but I always recommend learning how to do the packet capture so you can dive into the frames and see what you're looking
Mhm.
for. But this is a easier way to do that because Adrian Granados does a great way of displaying all of this data for us.
And this is the information coming from the beacon frames, if you want to
Yeah,
compare what you have in Wireshark. Okay. And then I guess what we can talk about is device support. I
yeah,
think I have a couple of. So this one is okay. This one is from Apple, but I want to show you guys this. There's a web page on the Juniper Mist documentation page, and they have a page called "Practical Consideration for Deploying Wi-Fi 6E."
hmm
And in this document, they have something called client device support for OWE and WPA3. And if we look at it, they kind of detail it per OS. And they're telling us that on Android version 10 and above supports OWE. On Windows 10 for Intel NICs with specific drivers. And then it's a Chrome OS not yet supported, and Apple not yet supported. Okay.
But wait,
And this, yeah, the Apple piece, it's, I guess it changed in the meantime, and they put out this article, Apple, I think last month. I think it was on the 27th of March 2023, and on their support website, and I guess we'll put the link in the show notes,
yeah,
but they are telling us that now for OWE, iOS 16, iPad OS 16.1, Mac OS 13 or later, add support for OWE, but it's not for all model. And
yeah,
the detail for which model it is. So for iPhone, iPad, I'll let you guys, take a look
yeah,
at it. But
yeah. I
they
don't
they
see
pretty
Apple
much
Watch
added.
on there.
You don't see Apple Watch. Yeah, no, yeah, they maybe it was connected. I don't know, on the transition mode one.
Possibly, yeah,
So apparently Apple added OWE support
yeah.
on that phone, which was interesting because I tested it from my phone, and I have an iPhone 13 which matches their requirement,
Yeah.
and on my iPhone I had version 16.3, and I wasn't able to connect to
Oh,
OWE network when I
that's
tested it
interesting.
2 days ago. So I
Which
noticed
is,
that
yeah,
there's a
that's,
new version available, 16.4. So
yeah.
maybe
Maybe it
that
fixes
one
some
will give
bugs.
me.
Yeah, because I have the same version as you, and I connect just fine to
Okay.
OWE with my iPhone and also my M2 Mac. Um, and so that's interesting.
Yeah.
I know my Intel Mac doesn't connect. I know that, and I wanted it that way just so I have a device that doesn't connect, just to see what it looks like. But again, for higher ed, this is going to be the challenge, right?
Hmm.
We are going to get devices that are too old. So transition mode is probably the best way to go because even in my environment, I am hesitant to enable just OWE, and because I don't want the complaints. I know it's going to come. We have plenty of devices that are very old and just do not support some of the newer protocols. So it's just something to consider, something you need to take inventory of, at least know what your device types are, what versions are running. You may have to go out in the field and get an idea. But for enterprises where they control the devices, you will have more of an idea of what your plan will be to go to 6 gigahertz and with OWE and WPA3. So um, just there's a lot of resources available now, especially that Juniper one, Apple's website. I guess we
Hmm.
need to find one from Intel on the drivers supported.
Yes, there's one on Intel, and I moved away. Let me share my screen again. It's actually linked on that missed page, but they have here Intel support for OWE. They tell you which
Oh, hold on one
cards,
sec.
the 210, 211. Yeah. Um, so they tell you which card, and I believe there's a driver, minimum driver, 21.90.3 or later.
Yeah.
So that information will add it to the
Okay.
show
We'll
notes
add
as
that
well.
to show notes. We'll add the pcap files to the show notes as well. All the resources that we've used, the RFC, link to the RFC. Um, Maybe we can share some of the filters that were being used so you can try to find it specifically and using kind of the search filter for Wi-Fi Explorer as well. But interested to know what you guys think about OWE. Is it something you're planning to transition to? Um, is it something you want to use, or are you just going to skip it altogether and maybe it doesn't make sense? Let us know in the show notes. This is going to be episode number 316. So cleartosend.net/316. That'll take you directly there. Um,
Hmm.
any other closing notes, Francois?
Yes, actually, in the meantime, I just tried to connect my phone to OW. Am I still sharing? Can you still see my screen?
I don't think it's working anymore. Yeah, it's
Let
like
me see.
showing my face instead of your screen. Hold on. There you go.
Okay, let me
Oh,
try
no,
again.
now it's just me.
Okay, I'm going to try again. Let me know when you can see my screen.
Yeah,
Okay,
I can see
perfect.
your screen.
So in the meantime, I updated my iPhone, I guess at the beginning of the episodes, and then I reconnected to my OWE network, and now you can see that I'm actually connected using OWE.
Yeah,
So I guess for my phone, the 16.3 didn't work, but the 16.4, and I can,
possibly a bug
yeah,
then.
yeah,
And I don't like how
16.4.1.
Juniper shows it on the screen because you are connected via OWE, but it says WPA3-OWE. So it's kind of
Yes.
lumping OWE with WPA3 in there. But they're
Yeah, the security. I'm
yeah.
not too sure what's.
That's
Oh,
how
maybe
they
it's
that's how they
because we have
display it.
encryption. Yeah,
Yeah.
yeah,
But your SSID is configured for OWE. So
yes, yes.
that's just
It's
something to note.
OWE. I disable the transition mode, so it's OWE only.
Specifically, yeah, only.
Yeah,
And also with Juniper Mist specifically, you can stop sharing your screen if you want. Uh,
yeah.
with Juniper Mist specifically, when you are searching for clients, you can actually filter it based on just the security type. And so
Hmm.
when you filter it, you can do the SSID if you want. And when you do have transition mode, both SSIDs will show the open and the OWE SSID. But you can also filter it just based on security type. So you can actually select, it'll say OWE in there, but it'll also say WPA3-OWE. So that's the one you have to select. And that'll filter everything that falls under that security type. So just something to note with how Juniper Mist specifically filters that data for you. Because I got confused initially. I'm like, wait, I don't have WPA3 configured. And I thought, oh, okay. It's just showing me WPA3-OWE. It's just lumping both of those together. But yep, kind of a dive into OWE, the technical details around it, a little talk about deployment methods. The way I'm deploying it is going through OWE transition mode, doing very small scale tests right now. And I'm also trying to see what it looks like if I do a slow rollout, meaning I have some buildings with OWE transition mode and some buildings with open. And I'm specifically looking at user experience where does the device give you a notification saying, hey, you previously connected to this SSID under this security and it's no longer that security type. So that's what I'm looking for, because I don't want to get an increase in tickets asking why it's not secure anymore.
Mhm. Yeah, so hopefully this was informative for you guys. Let us know if you're using different vendors, then they implement transition mode in a different way. Just let us know as well. It would be nice to exchange on that topic.
Yep.
Um, yeah, it's been a pleasure, Well,
Yep. Thank you guys for listening, and we'll see you in the next episode. Bye.
see you guys. Bye bye.
This episode is sponsored by Optify. Optify is a taskbar applet for Windows and Mac OS that helps you keep track of your device's Wi-Fi and network connection information. With Optify, you can easily monitor crucial details like channel widths, signal strength, access point manufacturers, and more, all from a small window that sits conveniently in your taskbar. Plus, with live remote monitoring, you can even share data with remote users and get real-time analysis. Just create an account at app.optify.com to access customized presets and take your network monitoring to the next level. Download a free trial at optify.com.